everything kind of went away here. Okay, I'm back. All right, so I don't know what question, if you even heard what I said. So up here, we had an x to the third, and it reduced down to an x to the second. Here we have an x to the fourth, so what is this going to reduce down to?
To the third?
Yeah, to the third. Yeah, I don't know. I had an issue this morning or this afternoon with some stuff too. So this is going to be 1x to the third plus 2x to the second plus 6x plus 11 with a remainder of 27. Okay. So
And
here,
where does this 27 goes? It's just like a remainder, that's it?
yeah, it's just going to be a remainder. Okay. And I'm about right now ready to give you one to do. And when you're going to see some significance to that remainder. Okay.
But could you explain again where that 0 came from?
Oh, because you don't have any x cubes here, right? So it's x to the fourth plus 2x squared. You don't have an x cubed. So you have to, you basically have 0x cubes. So then you have to put that 0 in there as a placeholder.
So if they don't fall in line with each other, then we always put a 0 in?
If you don't have, so see, this is x to the fourth plus 2x squared. So if you don't have, here, let me give you another thing. So if you had x to the fourth plus 3, right, and you were going to divide that by x minus 1, say, you would have to have 1 and a 0 for x cubed, a 0 for x squared, and a 0 for x. So you have to have those placeholders. That's what I'm saying. If there's not a power there, then you have to put a placeholder, a 0 in there. Okay, here's what I'm going to do. I'm going to give you one. Okay, I'm going to put it in the chat here. And I want you to divide this using synthetic division. And I'm just going to put divide by x plus 2. When you're done, I want you to graph it there. So put that graph, go ahead and divide it. All right, graph in a Desmos, and then come back and tell me, and then have the x-intercepts. Okay, so I'm going to give you a few minutes to do that. Here's what I want to know. And there's a lot of stuff up here. All right. So, let's just go ahead and walk through the division on this. We're dividing it by x plus 2. So then what number would I put in the little backwards L there?
-2.
There you go. Good job. Good job. Okay, so I'm bringing this down, bringing this down. Okay, first thing, what do you notice about this one and that's different than the other ones? There's something different about this one.
The remainder is 0.
Yes, the remainder is 0. Okay, cool. What are your x-intercepts?
1 and 3.
Oh, I think there's another one. The x-intercepts are that. There should be one more. Yeah, -2. Very good. Okay, -2. Now, notice that the number that we divided by and the x-intercept are the same. Okay, so let's try this out and see if that works again. So that's 2, -4, -10, and 12. And we're going to divide it by 1 because that's the x-intercept. 2, 2, -2, -2, -12, -12, 0. So if your remainder is 0, what does that tell you about the number that you're dividing by?
It's the same.
No. So if your remainder is 0, what does that tell you about that number that you're dividing by?
It goes evenly, like divisible.
You're right. You're right. It's perfectly divisible. But remember that up here, okay, right there, we divided by -2. We got a remainder of 0, and it was an x-intercept. Here, I said, let's try 1. So we divided by 1. That was an x-intercept. And our remainder is 0.
You could have chosen any other number from the x-intercepts.
Say that again?
So when you decided to divide by 1, you could have choose like 3 or -2.
Yeah, and what would we have? What would we've gotten for a remainder?
0.
Yeah, exactly. That's
see.
exactly right. Okay, so when you divide by something and you get a remainder of 0, okay, that means that is a solution or x-intercept. Okay, so if I divide by a number, this is using synthetic division, okay, if I divide by a number into a polynomial and the remainder is 0, then the number is an x-intercept. Oops. But remember, I said x-intercepts are zeros and they're roots. So it also carries over into that. All right, and that's we're kind of come back to there. But this is pretty important, and this is kind of basically what that remainder theorem says. All right, it basically says, hey, if you take a polynomial, you divide it by some number, right, and synthetic division, your remainder is 0, then that's an x-intercept. And it's perfect, and it's also what the factor theorem says. Okay, and I'll show you that in a second.
Where did the 1 and the 3 come from as the intercept?
If you take that original, if you take that polynomial that I gave you, the 2x cubed minus 4x squared minus 10x plus 12, and you graph that in decimals, your x-intercepts are going to be -2, 1, and 3.
Oh, okay. So it is from looking at decimals and not just looking at the equation.
Right. Yeah, that equation. See, all these equations are now in standard form, and so they don't tell us anything about what the factors are, and we can't factor it. It's impossible to factor it. So the only way you can factor it is by graphing it and hoping that it has nice numbers.
Okay, thank you.
Yep. Okay. So I'm going to put another one in here. Or did I put 2 of them in there? I can't even remember now. I think I just gave you one. So did I just give you one? Yeah, I just did. So let's go 2x to the third minus 12x squared plus 22x minus 12. All right, and we're going to divide that x minus 1. Okay? See what happens. Tell me if x minus 1 is a factor. Or if x minus 1 is a factor, then that means that 1 is an x-intercept. Okay? So go check it out. Do synthetic division on it. Okay, so let's see what happens here. You take this to -12, 22, -12, divided by x minus 1. So what are we going to put in the little backwards L?
1.
1. Very good. Drop that down. 2, -10, -10, 12, 12, 0. So that means that x minus 1 is a factor. Okay? So if I try to write this in factored form, then this would be one of them. Okay? This would be one of them. Now, I don't know what the other ones are, but I know that that's going to be one of them. Okay? And that's what the remainder and the factor theorem say. If you get a remainder of 0, then that, whatever you divide by, is an x-intercept. And then x minus 1 is a factor, because that's what you divided by. You divided by x minus 1, and you got a 0. Okay? So that's what those things say. And really, that's pretty much the most important thing that come out of there. Now, hang in there for a little bit here. We're almost done. You got to hang in there, okay? I want to show you this. And this is in your book. Okay? It talks about something called Descartes' rule of signs. Now, this is something, again, that we just don't teach anymore. Okay? And the reason is because technology has replaced it. Right? You don't need to use Descartes' rule of signs. Right? And I'm going to show you some problems where in the book it's going to say use it and you don't need it. All right. The other thing, rational zeros theorem. Oh my gosh, this is, again, we don't do that anymore because we can graph it. Okay. You're not going to see this stuff ever again. It's just you're not. No one's ever going to ask you about Descartes' rule of signs or the rational zero theorem. Okay. All right. So I'm just showing you some of the stuff that's in the book. All right. That they talk about that we really don't need to worry about. Okay. I do want to show you one other thing. Here's synthetic division, by the way. It shows you that in there. Let's see. How do I want it? Let's do it this way. Okay, I'm going to give you this one. Let's go with x plus 2. All right. Okay, guys, here we go. Synthetic division. Okay, I'm going to set it up for you. And I want you to do the synthetic division and tell me what the remainder is. Okay? So go. We'll see who gets the remainder first here. Oh my goodness. There we go. There we go. Let's see if we got another one I want to see. I always like to make sure that. Let's get somebody else throw me another remainder in there. Good job, Jordan. Okay, cool. You guys all got negative 45. Okay, everybody's right. I'm going to go along with you. All right, here's what I'm going to do now. I'm going to take this 3, what did I have? X cubed and negative 2x squared and plus 4x minus 5. Okay? And I'm going to put in negative 2. So I'm going to go like this. Negative 2 cubed minus 2 times negative 2 squared plus 4 times negative 2 minus 5. I'm just going to have to work this out because, you know, I'm not exactly, see here, 2 times 4 plus negative 8 minus 5, negative 24 minus 8 plus a negative 8 minus 5. Wow, lots of minuses here. 32, 40, negative 45. How about that? That's the same as the remainder. Okay? So, if we divide by a negative 2, okay, then our remainder would be the same thing as this. We put that in for x. Okay? And it doesn't matter what number you divide by there. It's as if you put it in for x. Your remainder tells you that. So before, when we were getting all those remainders and you were asking me about what do I do with those, now you have all kinds of information. Okay? That, first of all, if it's 0, you know that it's an x-intercept and that combination makes a factor. And if it's not 0, then that's whatever number you divided by is what you would get if you put it in a function. Are we good on that?
Yes, thank you.
Okay. So there's another thing in there. I believe they're calling that the the immediate value theorem. Okay. We'll talk about that. All right. I don't know what this is. It's some cubic. Okay. Let's say that I put -1. I divide this cubic, whatever it is, by -1. Okay. My remainder is going to be this point up here, whatever that is. Okay, because that's the corresponding y. Are we good on that?
Yep.
All right. And that y value is going to be positive. Okay. So I did synthetic division. I put -1 in there, and I got a positive remainder. Nice. Now let's say that I go to -2. And I come down here. And I come over. And I get another y value. But that y value is negative. Okay? So this immediate value theorem tells you, well, if this value is negative and this value is positive, that means there's got to be some number between -1 and -2 that is an x-intercept. In other words, it's right here. It doesn't tell you what it is. It just says there's a root in there, okay, or there's an x-intercept in there. And that's what that theorem says. And really, it kind of makes sense, right? If you have one value that's negative and one value that's positive, you know that graph's got to cross the x-axis to get to the positive side. Okay? So that's what that thing says. And it's called the immediate, sorry, I'm getting it all messed up here. Intermediate, I mean to say. Value theorem. All right, so if this one is negative, this one is positive, then I know it's going to cross somewhere in between there. Okay. Now you want to, I mean, you just know it could cross 10 times, but I don't know. I just know it's going to cross there. Okay. It's got to cross. And that's what that says. So when you're doing problems on this assignment, okay, and I want to show you some of these. I want to stop this share. So on this assignment, 231, our first problems we're going to do is 11 through 16. And here's what this says. Use the remainder theorem to find the remainder when f of x is divided by x minus c. Then use the factor theorem to determine whether it's a factor. Okay? So what are we going to do? Well, we're going to take this thing right here, We're going to divide it by this using synthetic division. And if we get a remainder of 0, what are we going to say?
It's divisible.
We're going to say that x minus 2 is a factor. Okay? We're just going to say that x minus 2 is a factor. So when we do that, right, and we get a remainder of 0, then x minus 2 is a factor. That's it. That's all you have to do. Okay? Don't get thrown off by all this fancy stuff. The remainder theorem and the factor theorem. Just use synthetic division. Divide it. If you get 0, it's a factor. If you don't get 0, it's not a factor. Okay? So on 11 through 16, that's what you're going to do. Then I don't even have you doing any of these ones because, like I said, some of this stuff just isn't really necessary. The next block is 45 through 50. So that's up here. Use the rational zeros theorem to find all the real roots, or all the real zeros. Well, I know how I'm going to find all the real zeros. We're going to graph these. You're going to graph these in Desmos, and you're going to find all the real zeros. Remember that zeros, x-intercepts, and roots are all the same thing. So just graph it and find the x-intercepts. And you've already done that. You did that for the last homework, and you did it already this evening when I asked you to go find x-intercepts. Okay, so you're just graphing these. So I don't know whether you need to make some little mental notes or some sticky notes or something, but just graph them in Desmos. Okay. The rational zeros theorem is something that is so tedious and so long. You could do one problem with the rational zeros theorem. You can have all the rest of them done by then. That's how bad it is. Okay. The next block is 57 through 64. Solve each one. What are you going to do? You're going to graph it in Desmos. Find the x-intercepts. That's all you got to do. Find the x-intercepts. See, I mean, that's why that's all you got to do. Okay. Find the x-intercepts. And let's see, 69. Now on the bounds. So when you graph this, let's go ahead and graph one of those guys. Let's see here. Let me get rid of this, get rid of this. I think you can still see what I'm doing. X to the 4th, y equals x to the 4th minus 3x squared minus 4. So it wants to know the bounds. So I'm going to look and check real quick, but I believe that's what they want, is those numbers right there. Yeah, upper and lower bounds. That's what they want. So then you graph it, and there's your lower bound. Right there, negative 6.25. Because it never goes lower than that. Okay? We call that bounded. It never goes lower than that number. So it's bounded. It doesn't have an upper bound because it's going up forever. Okay? So you're just going to graph it. Find the lowest point and the upper point. If it's flipped, now you have an upper bound. Okay? Let's see if we can zoom out on this a little bit. Let's see if we can fix the screen here. Oops, I don't want that one. I want this one. You can see that that thing's just going down. Okay. So there's our upper bound, negative 4. Or, yeah, negative 4. We don't care about the 0. We just care about the upper bound. All right. So upper, lower. It all kind of depends on, oops.
So it's like the minimum and max?
Yeah, exactly. Exactly. Let's see here. But a lot of these, you're just going to graph them in Desmos and answer the questions. 69 through 72. Oh, that's what we just did. 79 through 81. Here it says use that immediate value theorem to show that each polynomial has a zero. So on this, I wish I could make this just a little bit bigger, but so you're going to take this one, okay, and use synthetic division. Or you can even graph it in Desmos. If it crosses between 0 and 1, you did it. But you can, if you want to, use synthetic division on 0. So here, if you put 0 in here, you're going to get negative 1. Okay, so if you put 0 in all these x's, they're going to go away, and you're just going to be left with a negative 1. If you do synthetic division on 1, and you get a positive value, then you know that it has to cross between 0 and 1. But again, you can graph it in Desmos and show that. Okay. Yeah, and then you can just tell me, I graphed this in Desmos and this is what it showed me. Okay. That's all I really need. And then that's the end of those problems. So, yeah, I mean, really, you're just going to be graphing a lot of stuff in Desmos, looking for x-intercepts, and doing some synthetic division. Okay. So I think that's pretty much it with that stuff. You don't have to worry about some of those terminologies. Be careful with all that junk. We've almost went a long time here. Let me just tell you. So when the Zoom thing crashed, and right prior to that, when some things were going wacky, my recording